with the lipid, and now you've got your protein, and you backfilled the membrane around the protein. And again, this method actually can address the issue of protein orientation, because if you address the protein with a capture reagent, it should in principle only go in one direction. So here's the actual reagents. Again, we've looked at this NTA type capture reagent if you want to capture a his tag membrane protein. And if you look at that, so if we just try to capture a protein that's been expressed with a his tag, and we look at our surface plasmid resonance as a response of protein binding to the surface for both our CB2 receptor as well as another lipoprotein, we can see that basically there's a good response between the SPR and the amount of protein we expect to see as we add it. That shows that protein is actually being coating the surfaces that are created by these capture reagents. So the last, I think, introduction I'd like to give you in terms of membrane reconstitution has to do with creating multi-layer surfaces. And in this case, we've been successful in actually in taking liposomes and actually laying them down, in this case, to create multi-layer bilayers. So the liposomes have the protein cargo. In this case, the example would be work with an ion channel. We can create multi-layers of this bilayer that spontaneous forms from bringing these liposomes down to the surface. And so the importance of this is if one's doing diffraction type measurements, the multi-layers actually give you, again, a 2D-like pseudocrystalline structure that one can then use to get an understanding of the positioning of the protein.